Okay, so in front of us we have an RTX 3090. This is the TUF model by Asus. If you've come across this video or this channel hoping to get your graphics card repaired by somebody like myself, I should note that I now have a Discord server with a repair request section. I've asked a handful of experts living in Germany, the US and the UK to list their contact details so that you can contact them to get your graphics card fixed. And also the Discord is linked in the description. Like all the broken cards that we get, we want to first start by checking for a short on the base voltage rails. To begin, we're going to start with the PCI Express slot itself. Oh, by the way, I have my multimeter in continuity mode. If I probe ground or something connected to ground, my multimeter beeps. So, if you don't know, the first 3 pins are 12 volts, and we're good. If we start at this notch and go 4 pins left, we'll find 3.3 volts, and we're good. So now we want to check 12 volts at the 2 external 8 pins. Checking this one on the right, we're perfectly good, and checking this one on the left, we're perfectly good. Okay, so we're not short on the base voltage rails. Okay. Now we want to take a resistance measurement of the voltage rails generated by the card itself. So first we're going to start with what I presume is 5 volts. Okay, so 2.1 kilo ohms. Perfectly normal if it is 5 volts, and any other rail actually, unless it's, the PEX or whatever, but I doubt that. Now we want to check 1.8 volts. I should note that 1.8 volts is over here. So as you can see, we have 617, 620 ohms. Again, this is 1.8 volts is a little bit hard to judge on these newer ampere cards. It's not like Pascal where it's supposed to be a very strict number and any deviation suggests a problem with the card itself. So now we want to check the memory. Yep. So 40 ohms is relatively normal for 24 gigabytes of Micron GDDR6X. And now finally we want to check the PEX rail, which is this over here. 6.7 ohms, so that's relatively normal. I normally expect to see about 6 ohms. Since the card is not short on any power rail, let's go ahead and turn it on and see what we're missing. Okay, turning the card on. Okay, so first let's check, we're just going to start at 5 volts. Okay, the GPU itself is cold, so that's fine. So like I said, we're going to start at 5 volts. 4.991, that's normal, that's good. Now let's check 1.8 volts, which by the way is over here, just in case you forgot already. 1.8, that's good. So the next rail to turn on, and by the way, 1.8 volts turns on after 5 volts. Next rail to turn on that's right, the V-core. I should note that this is actually incorrect. As you see later in the video, the power sequencing for a lot of Asus cards is actually distinct from other manufacturers. We're missing the V-core. So because we don't have the V-core, we also won't have the PEX rail. The PEX rail turns on after the V-core. As you can see, 0 volts. And because we don't have the V-core, we also won't have the memory. Okay. So we're missing the V-core, so we have to, I've actually been given a bit of a hint by the owner, so they claim that they knocked something off over here, so this might be the cause of our problems, but we'll have to investigate further. Okay, so at the moment we're more or less zooming in on the portion of the circuit with the missing component. So this component, by the way, that's missing, I've cleaned the pads, that's why it doesn't seem so ripped off. So, this component is responsible for generating the enable signal for our GS9216 buck converter. This buck converter is of course responsible for powering the PEX rail. And by the way, it is a logical AND gate. Even though I didn't see the part that was ripped off, I already know it's a logical AND gate based off of experience. So anyways, let's go ahead and replace this component. Okay. So as you saw, I replaced the logical AND, I installed a logical AND gate. So if you don't know, this logical AND gate is a 74LVC1G08. It's very common in graphics cards. Anyways, let's go ahead and turn the card on and see if it boots. So, well, as you can tell, the standard ordering for NVIDIA cards actually doesn't hold for this card. And in particular, we also have a BIOS splash screen, by the way. So let's turn the card off before it overheats. Anyways, so like I said, the standard ordering doesn't actually hold for this card, oddly enough. I know, for example, on the Strix 1050 Ti, the standard ordering also doesn't work. For example, 1.8 volts turns on as soon as the base voltage rails turn on, and not after 5 volts, and it also doesn't depend on 5 volts, which is a little bit weird. And as you can see in this card, the V-core turns on after, well, it requires the PEX rail to work, which is, or at least it requires this component to work, and this component outputs the enable signal for the PEX rail and probably to something else over on the side of the board. But in either case, let's put the cooler back on and let's see the card in all of its glory. Okay, So as you can see, the card's running game. We're actually looking at a video of the card being stress tested as I want to talk over this. So the lesson for this particular video is that the power sequencing that you often find on NVIDIA cards is not always correct. So the standard power sequencing, as many of you know, is that 5 volts turns on first, followed by 1.8 volts, then the V core, and then after which the memory and the PEX turn on together but independently. But for a lot of Asus cards, and in particular RTX 30 series cards, 3080s and 3090s, I'm told that the power sequencing is 5 volts, 1.8 volts, PEX, V-core, and then memory. While I can tell you that on some other cards like Asus Expeditions RX 570s and Strix 1050 Ti's, again, the power sequencing is different from what you'd expect to see from a comparable card. But otherwise, I hope you learned something watching this video. If you feel like my channel has helped you out, I have a Patreon link in the description. Otherwise, thanks for watching, and hopefully I'll see you in the next one.